Hello out there again, fans, and welcome to another video by the team here at BlenderTech.com. That's BlenderTek.com. Unity videos will soon have their own website when the requirement is there. We currently use version 4.5.5F1 Pro. Please like the video if it helps in any way or you learn something useful, and also subscribe for more videos on Unity 3D, Blender, and coding. The team adds at least one quality video a day, and don't forget, create your way. In today's video, lesson 3, which may be slightly longer since it's put into one whole part, we will be looking at how the game camera system works in Unity. A lot of this will be an explanation lecture at first, and then we will get into some actual tutorial follow along fun. I promise only the first bit will be explanations. Everything learnt can be applied to your projects, and in the end, you will have the proper camera setup needed for your game, projects, or ideas. Cameras are essential for displaying your game to the player. Cameras can be customized, scripted, or even parented to other objects to follow them. This way you can achieve nearly any effect you might imagine or need, only limited by your creativity and skills. For a puzzle game, you might create a static camera to see the entire puzzle scene you've set up. For a shooter, you would have the camera parented to the player at eye level. For a racing game, you would have the camera parented also, but follow the car from behind a short distance instead. You can even create multiple cameras so that the player can select different views. In that instant, you would assign each camera view a different depth value. Cameras are drawn in your game from low number depth values to higher numbers. Using depth along with the normalized viewport rectangle setting at the same time lets you create mini-maps, mirrors, split-screen multiplayer, and more. Before we get started with the lesson, let me give you some quick hints, tips, and tricks to take with you. Number 1. Cameras can be instanated, parented, and scripted just like any other game object. 2. In a racing game, to increase the sense of speed, use a high field of view value. 3. Cameras can be used in physics simulations by adding a rigid body component to your camera game object. 4. You can have an infinite number of cameras in your scenes. 5. Orthographic cameras are great not only for 2D games, but for making 3D user interfaces or menus. 6. If you get flickering or artifacts, your near plane value probably has to be increased. 7. Unity Pro has more camera effects and options. 8. Unity has pre-installed camera scripts found in Components Camera Control with your main camera selected and when you go to add component. Play with these to see what's possible with cameras. First of all, as you may have noticed before, when you create a new project in Unity, a stock camera is created called main camera. You may not know how to use it though, and how the different settings work. We will be trying to explain that as fun and interactively as possible in the lesson today. The fun stuff starts after I explain the most commonly used camera settings. Let's start off as always by creating a new project for today's lesson. I will emphasize as always to keep your projects organized because eventually you'll have dozens of projects on the go with hundreds of subfolders with thousands of files. I have already chosen a path. So let's create our new project by going File, New Project. I'm going to paste my path in and then hit Create, and let's get started. Now that our stock scene is loaded, select the camera in the hierarchy window and let's look over the settings in the inspector window. In the inspector window, you'll see the camera has a component in it, understandably called camera. In this video, I'm going to explain the most used settings and what they do and what they mean. At any time, if you want to figure out any of the settings I skipped over or find out more details than I can explain without being extremely boring, then remember to press the little book icon with the question mark on it. These are scattered all over Unity for nearly every component, and Unity has great stock documentation. Also, it's local on your computer, so you don't always need to be online. The first setting I'll be explaining is background. This is self-explanatory. If you have no skybox, this will be the color filled around every other object in the camera's view. Unity defaults to the current camera's skybox, and if it has none, then it defaults back to the standard skybox set in the project's render settings. If there's no skybox there, then it defaults to our simple background setting here. Next up, culling mask. This allows you to choose what will be rendered by the camera. Remember in the Unity Physics Intro video part 2 called Physics Layers? We learned how to set up different physics layers and assign them to individual game objects so that only certain game objects had certain physical properties. This setting is similar to that. You can create essentially render layers and assign them to your game objects. This could be used so that one camera is set up for a main menu scene and other cameras for in-game and so on and so forth. Going down the list, projection is a pretty simple one. If you've used a 3D program like Blender, you know the difference between perspective and orthographic views. If you don't, Google it. Basically, orthographic means there is no perspective change, and the projection settings lets you choose between perspective view and orthographic. This could be useful for, say, 2D games, sprites, or pixel art, for example. If you select orthographic, a new setting comes up called size. You can see right here, the new setting of size comes up. This is simply the viewport size of the camera in orthographic view. Play around with it to find out how it affects the camera's game view with a simple scene. We will be doing that a little further along in this lesson. Field of view, or FOV, is an important setting. You may have played first-person shooters that let you change your FOV. This essentially lets you choose how wide of an angle the camera can see. You can only use this setting in perspective mode. Clipping planes is another important one. Similar again to 3D modeling programs like Blender, which calls it clipping distance, changing this sets a distance in units from the camera that it will start and stop rendering game objects. Near is the closest distance before objects start becoming rendered, and far is the furthest endpoint where the camera will stop rendering game objects. So again, think of it like clipping distance. Lastly, we're going to skip over to HDR. HDR allows the camera render to enable high dynamic range. If you didn't know what HDR stood for. For the rest of the values, again you can click on the little book with the question mark on it at the top of the camera's camera component. And if something confuses you, post on the forums or a third-party website. You can also ask in the comments and I'll try to explain it to you, or create an article on blendertech.com with pictures and short videos explaining them. I've now rambled too long and explained far too much. Let's get started with some fun stuff. First of all, we need a scene setup or else we won't see anything with our camera. Since this lesson is about cameras, let's position our camera first. Select the preset camera in the hierarchy window, and in the inspector window, we're going to change its position. Let's position it at 1, 3, -11. Make sure the settings are clear flags, skybox, background. We'll choose a nice sky blue, culling mask, everything, projection, perspective, field of view, 60, clipping planes of 0.3 for near, and far of 250, or we can actually leave it at 1000. It doesn't really matter in this instance. Viewport rectangle, leave it 0, 0, and 1, 1. That's the default. Depth, we can leave it -1 or change to 0 since that's our only camera, it doesn't matter. Rendering path, use player settings. Target texture, none. Occlusion culling, checked. And HDR, unchecked. These are the stock settings except for the background we changed. Now let's create a floor. If you forget how this is done, go to Game Object, Create Other, Plane. Let's name it Floor. As you can see in our hierarchy window, it's now named Floor instead of Plane. This box right here is where you name objects if you've forgotten. Position it at the origin, which is 0, 0, 0 if you forgot. Next, let's create some cubes which could represent anything such as players, terrain, or game models. Create it the same way as the plane. So we go game object, create other, cube. Position the first one at 0, 0.5, 1.5. Sorry, that's negative 1.5 for the first one. Create the second one the same way, and we're going to position it at 0, 0.5, 1.5. Now we're going to create a third one, and we're going to position it at negative 3.5, 0.5, negative 3.5. Let's make one last cube in the other corner. So the position for that is going to be 3, 0.5, again to bring it up to floor level. And for Z, the value is 4. So as you can see, we have one in each corner. To organize our cubes, let's create an empty at the origin. Do that by going game object, create empty. Let's rename it to representative cubes or something similar. Now we can parent each cube to it by clicking and holding down and then dragging it on top of our empty called representative cubes. As you can see, we now have a drop down menu of representative cubes where all our cubes are. They still remain where we put them, but this is basically a way of organizing our scene. This empty won't render in our view, and it won't be rendered at all. You cannot see it in the game at all. It's simply the parent of the cube, and the cube is the child. For example, if I move the representative cube empty up now, as you can see, our parented cube moves with it. So I'm going to change that back to 0, 0, 0, which is the origin. So keep parenting your cubes to it. And here's the trick. You can control and click to select more than one unit at a time or deselect. Or you can also shift click to select a whole row at once. So again, parent all our cubes to representative cubes. So they're now all childs of representative cubes. And like I said, if you move it up, it moves all our cubes with it. So that's a parenting example, and again, it's just a way to organize our scene. Let's create some lights so we can see more than our previous videos that had no lighting. Create another empty called lighting, and again we'll leave it at the origin of 0, 0, 0. Our first light will be a point light, which helps us see the shading of our game objects. To create it, go to Game Object, Create Other, Point Light. You'll now see the lighting our scene has changed dramatically. So to change that, we're going to position it at 0, 3, 1. You can now see it's a point light that helps us see where our cubes are in 3D space. Next, create a directional light, which helps break up the background view color. So for this one, Game Object, Create Other, Directional Light. We're going to position it way below the scene at 0, negative 50, 0. Make sure the rotation is 0. Sorry, I'm making a mistake again. Make sure the rotation is 270, 0, 0. That way, if you move around your scene to find it, you will notice that it's pointing straight up towards our scene. You'll see why we're doing that in a minute. Make its color bright green. We do that under the light component here, under color. We change it to any color we want, but in this case I'm going to use bright green because that way it's not any color of any of our axes, axi, and it's not the color of any of our cubes, and it's not the color of our background, so it'll stand out. So we've now assigned our directional light to be a bright green color. In fact, I'm going to make extremely bright green, as bright as it goes. The rest of it can be left to its stock settings. Actually, the intensity can be changed from 0.5 to 1. That makes sure that we're going to see it on the other objects that we're going to create. Now we're going to parent both of our lights to our lighting empty. Do you remember how to do that? You can do it one at a time by clicking and dragging, or you can select both of them using either shift or control and drag and drop it into lighting. Now lighting is our parent of our children lights. So again, this is for scene organization in this case. As you can see, even simple game scenes take a ton of prep work to set up. Continuing on, let's create two spheres which could represent background objects such as distant trees, a distant building, or something to that effect. These spheres are going to show off our directional lighting as I mentioned before. So select Game Object, Create Other, Sphere. We're going to position it at 4, 2, 25. So you won't see it anymore, but basically it's way off in the distance. And once we adjust our camera position, we'll be able to see it. Create one more sphere, so Game Object, Create Other, Sphere, and position it at -4, 2, 25. Once we get the game camera set up, you'll see the bottoms of these spheres will glow the bright green of our directional light. We can organize our scene more by creating another empty object at the origin called background spheres. And we're going to parent our spheres to background spheres, so everything's nice and organized. I believe that is all we need to illustrate everything in this lesson. Now let's have some fun. So now if we press play to go into game view, let's see what we've got set up. As you can see, we've got our cubes set up and they're lit by our direction or our point light, which is roughly right here. And you can see our spheres in the distance. The bottom of them are lit up bright green by our directional light, which is way down below our scene. So I believe that is all we need to illustrate everything in this lesson. Now let's have some fun. Uncheck play to get back to our scene view. So making sure we're in scene view, let's get started. So making sure main camera is selected in the hierarchy window so that we can play with the camera settings since this is a camera tutorial. Let's first play with FOV. If you've forgotten, that means field of view, since this is important when setting up cameras. Slide FOV all the way down to 1. As you can see in the camera preview, this really changes what it would look like in the game. If we slide it all the way down to 1, as you can see, we see nothing except for our background sky color. And you can see in the scene view, based on these lines here, that is what the camera can see, which happens to be nothing. Now increase it to a value over 100. As you can see, this zooms out and increases the perspective greatly. Over 100, we can't see our spheres anymore, and at the max value of 179, we cannot see our scene at all. It's not even a dot in our camera preview. So you can keep playing with this value to see what kind of effect it has on your scene, and leave it at the stock value of 60 when you're done. Now you can either type that value in as I did there, or you can right click on the camera title, which is above clear flags here, and right clicking camera, you can hit reset. This resets everything to the stock settings. Now this changed our background color, so we just simply have to change that back to a nice sky blue. But we're going to be using that right click reset to quickly reset our settings when we play with them. Next, let's see the difference between perspective and orthographic projection. I described at the beginning the difference. Change the projection drop-down box from perspective to orthographic. Notice in the camera preview what's happened? Our spheres are now the same size as the cubes. So our spheres are far away, or that were far away, are not smaller anymore, and they're actually a similar scale to the cubes. And if I'm not mistaken, in this view, they're actually an exact same scale as the cubes. Even though in perspective view, they look like they were scaled way down because they were so far away in the x-axis. When creating 2D games, this is very useful, or when using simple 2D sprites instead of 3D models or pixel art. Notice we don't have a field of view setting here anymore. Instead, we have a size setting. This still zooms in and out, but without the perspective change, so the scale of the foreground to background objects is exactly the same. Try playing around with the size value. I suggest starting at 2 and moving up in single increments to 12 or more. So we can either, like I said, type in the value 2, or I'll show you another trick. You can see when we hover over size here, these little arrows come up. That allows you to slide your value. So let's start around 1.32 and slowly slide it up to above 12. As you can see, it still zooms, kind of like perspective mode, but our cubes and spheres still stay the exact same size. That's because in orthographic view, it takes away all perspective. So now that we're over 12, as you can see, we're zoomed way out, but if we hit play, our cubes and spheres are still the same size. So uncheck play to get back to scene view. Let's reset this back to the stock values again. We're going to use the right click and reset trick and change our sky color back to a nice blue. Let's play with clipping planes now. I explained what they do at the beginning. Change the far value to 15 to see the effect. I'm going to simply type in 15. Now watch in the camera view, or camera preview I guess, what happens when I type in 15. As you can see, it's cut away our spheres completely. So it's only rendering out to 15 units. And thus, we can't see our spheres because they're 25 units away. You can change it to around 5 or 6, 7, 7 to get an even more extreme effect. So now it's only rendering out 7 units from where the camera is, and that happens to just leave us with roughly 2 or 3 units of the floor. In this case, it's not very much. It's about 1 unit because we can't see this cube here. So you can play with the near and far values to see what they do and how they affect your scene. Notice what the near value does? That changes how much of the foreground you see. So if we change it to around 12 and hit play, since the camera preview is small, we can still see our spheres, but we can only see 2 of our 4 cubes now and about half of our floor. That's because it's rendering from 12 units all the way up to 170 units. So again, play with the near and far values to see how it affects your camera's view. When you're done, you can reset them back to 0.3 and 250. But again, we're going to use the right click reset value trick to get back to the stock settings. And again, we're just going to set our sky color and we're done deal. Another thing we can do is adjust our camera view some more. So in scene view, which we're in already, make sure we have the camera still selected in the hierarchy window. Whoops, I just parented. Control Z to undo that. Make sure you have the main camera selected in the hierarchy window, and in the inspector window, as we were before, we're going to do some adjusting of where the camera is positioned, which is what I basically did at the beginning. I had my values preset, but I'm going to show you how you can adjust it manually now. So first we're going to choose the translate tool, which is the 4 arrows, or you can just press the hotkey W on your keyboard. Do you remember your hotkeys from before? Do you also remember the double click to focus trick? Double click on the camera in the hierarchy window to focus on the camera game object within scene view. So I'm going to do that now. As you can see, it's now focused right on our camera. So I'm going to zoom in so that we can see a little bit better with our handles here. At any time, you can double click on any object and it'll instantly zoom to it. So that's a good way to find objects when you have hundreds of them in a single scene and you have giant maps and giant games. But anyways, double click on main camera so that we can adjust its view. So using the handles, play around with them and see how it changes your view using the camera preview. You can adjust it up and down, forward and back, and left and right. And if you want a closer view, you can always press play again to go into the game view. And uncheck play to go back to scene view. So I'm going to set it back to the settings we had before by Control Zing. There we go, that's where it was set at before. So the next tool is the rotate tool, which is hotkey E. So now you can use these little circles here to rotate the view to different angles. You can rotate it up and down, you can rotate it left and right, and you can rotate it around its Z-axis, so you can tilt it. So you can play around with those to get a different view. Play around with both the translate and the rotate tools to get a better view of our scene from basically kind of a top-up, angled-down view. I'll show you how to do that now. We're going to move it forward a bit until we're closer to our floor. Then we're going to double-click on main camera again to focus it. That's called focusing, if I didn't mention that before. And now using the rotate hotkey of E, or pressing the button, I'm going to rotate it along the X-axis, down a little bit, so that we have kind of a top-down view. So now we can see all of our cubes and our spheres, except for one cube. So let's go back to the translate tool, hotkey W, and we need to move it either left or right. So there you go, we can now see all our cubes and our spheres. Let's press play to see what it looks like. So we've now changed our view manually to be able to see all of our cubes, our floor. We have a little bit of lighting here from our single point light, and we can see our spheres in the distance lit up from the bottom with our directional light. Uncheck play to go back to scene view. So you can play with that to get any view you like. This is the goal that I wanted for you, to get kind of an overhead angled down view of our basic scene setup. Like I said, the cubes can represent trees, they can represent players, they can represent enemies, they can represent walls, they can represent anything. They're just a basic representation for now. Thus, that's why I called them representative, that's hard to say, representative cubes. Lastly, the scaling tool, hotkey R. Like I said, do you remember your hotkeys, W-E-R? Notice how it changes, and notice how they're in line on your keyboard. Let's try scaling our camera. Notice how scaling your camera up has no effect on the view? This is one thing you can remember. It does absolutely nothing in perspective nor orthographic. Scaling does absolutely nothing. So we can always reset our camera again by right-clicking and reset, and it goes back to our stock values that we put in. So with all this lecture and playing around, you should have enough knowledge stored in your brain compartments and D compartments to set up nearly any scene in Unity that you require. At this point, you can play around with the camera some more. If you're having issue and want the Unity project file, leave a comment and I'll upload it to the website. We also want comments on what you'd like to see, whether it be Unity, Blender, programming, Crazy Bump, Shader Map, Photoshop, absolutely anything that you'd like tutorials, guides, and the like on. The more input from you, the community, the better our videos become. Our goal is to have all paid content on the internet that you would normally find for learning things like this. We want this for free on YouTube, and taking any slight revenue to create better and better websites and videos, as well as text and image guides and articles in the future. We essentially want all information for free, just like Wikipedia's goal, to have all the world's information for free. Thanks for watching this video from the team here at blendertech.com. Again, that's blendertech.com. If you enjoyed this video and it helped, please like it. Don't forget to subscribe for more Unity 3D, Blender, and coding tutorial videos. We try to add between 3 to 10 a day. If for some reason you dislike this video, don't just leave. Please add a comment instead that tells us what we can improve on so that each video gets better and better. For private concerns, we can be emailed at info@blendertech.com. We also love input as to what we should add more of and tutorial requests. See you next time, and remember, create your way.